Hello, so this is my second of two Year 12 Research Methods Psychology AQA revision videos. In my first video I looked at mainly the experimental method, aims and hypotheses, IVDV, types of experiment, design, sampling, etc. So this video we're going to go on to look at the non-experimental side of things, so more the observation, self-report, etc. Something I didn't cover in the last one was ethics, so let's start there. 5 ethical considerations you need to be aware of: consent, right to withdraw, deception, confidentiality, and protection from harm. For these, you don't necessarily need to know strengths and weaknesses, but you do need to know how to overcome these ethical issues. Consent is what it says on the tin. Participants must agree to take part in the study. How to deal with this? Well, you gain consent. You ask them in the best possible way. You'd have a consent form. Where participants are told a bit about the study. They know mainly what they're getting involved with without giving too much away, so that people would understand the aim of the study. Well, no, they may need to know the aim, but without changing their behaviour, so you get demand characteristics. But that's not always possible. Sometimes participants need to be deceived. We'll talk about that in a moment. But also sometimes participants might not even know they're in a study. In those sorts of cases, there are other types of consent. So there's presumptive consent, there's prior general consent. So presumptive consent is you'd ask a similar sort of people, are they happy with this? So say you wanted to do a study on your teachers in class, their behaviour in lessons, you probably wouldn't ask them because they would change their behaviour. So you might ask another set of teachers, what would their thoughts be if students were recording their behaviours, and if they said they think it would be okay, it's not a problem, then you can get presumptive consent. Prior general consent, universities use this. So when you start a university course, sometimes you sign a form saying you're happy to take part in a study. You don't know when that's going to be, and at some point you might then end up finding yourself involved in a study, even though you haven't agreed to take part in that particular study. Next, you've got right to withdraw. Participants should be allowed to leave the study. Excuse me. A good example of this not happening might be the Milgram study, when participants said, I'd like to leave, I'd like to stop, and the experimenter said, no, you must continue. How do you deal with this? Well, you let participants leave. Important part here is that actually participants are considered part of the study from the moment you approach them. So actually when you go up and say, would you like to take part in the study? If they say no, that's part of the right to withdraw process. The other end of it is even after they've taken part in the study. So they might have happily agreed, happily taken part, you've got all their data, and then you debrief them and you tell them what it's really about. If they say, oh, actually I'm not happy with this, at that point they're allowed to take their data away as well. So that's part of right to withdraw. Another way to deal with it. With the debrief, you tell them what it's all about afterwards. Next, we've got deception. Ideally, participants shouldn't be lied to, and again, there are some times where if you tell the participant exactly what the study is about, then it might change their behaviour. So maybe you would tell them that they're taking part in a memory study rather than actually the study they're taking part in, such as obedience, which is Milgram's study. But what you should do is you should debrief them at the end and tell them the true aims of the study, and then this links to right to withdraw. So all of these ethical guidelines link to one another. You then got confidentiality. There is technically another one with privacy. They are slightly different. So confidential, you shouldn't release any details that would link the data or link the participants to the study, so that's names, addresses, photographs, etc. And privacy as well, so participants should have the right to privacy, and you should only be taking data in the study that you've already got consent to take. And then finally, protection from harm. So this is both psychological and physiological harm, so you can't start cutting people and say it's part of psychology, I'm afraid. But also psychological, the good rule here is participants should leave the experiment in the same frame of mind as they entered it, if at all possible. You should also offer areas where they can get help, so your contact number afterwards as part of the debrief, maybe the contact number of someone else at the institute if they don't trust you, and if they don't trust the institute, then maybe a further contact. So if the study's to do with depression, you might offer the Samaritan's number so they can talk to someone who's a bit more independent. Next then we'll get on to observations. Observations are a bit strange in terms of there are lots of different types of observation. So the main two types of observation are either controlled or naturalistic. Again, they kind of do what they say on the tin. So a controlled observation is where you control some aspect of the environment. Ainsworth's strange situation was a controlled observation. There was a two-way mirror there. It was set up like a playroom, but it wasn't an actual playroom. This allowed for lots of control, maybe more internal validity, replicability. We could test infants over and over again and get the same results, but actually it maybe lacked a bit of mundane realism, external validity, because it wasn't a real playroom. The other way of doing this would have been a naturalistic observation, and this is where you actually go to a real world setting. So for example, in attachment, if you really wanted to know what a child and a mother's attachment might be like, you might go and observe them in the park. Not as weird as it sounds, you would obviously get consent and things first. So that's obviously going to give you more realistic outcomes. So you get external validity or ecological validity would be better, but there you haven't got the same level of control. It would be harder to replicate a child and a mother's behaviour in the park than it would be the way that Ainsworth did it. There's also a categorisation called participant or non-participant observations. So participant observation is where the researcher gets involved. So this would be like Zimbardo's prison experiment. Zimbardo cast himself as the prison warden. He was involved in the study. So that was a controlled participant observation because the experimenter was involved there. If the experimenter is not involved, it's just called a non-participant observation. The benefit of that is that you can potentially get richer detail. There's more control for the experimenter. So obviously Zimbardo kind of manipulated the prison environment to the way that he wanted, but that he has been heavily criticised for that since, because actually that might have then changed the behaviour. You also struggle to get subjectivity. You struggle to get objectivity, so you potentially get more subjective responses where the it's hard to stay outside of it and stay at arm's length and really see what's going on if you're actually involved in it. So that's an issue. Another categorization is covert or overt. So if you're covert, you're undercover, like James Bond. And if you're overt, you're out in the open. People know what's going on. And again, this will have an impact on how people react. So for a covert observation, less people know what's going on. But again, if you're hid in the bushes in the park and you're observing children, you will get arrested. You can't do that in the name of psychology. So it'd be better to be overt, but that might change behaviour. So you've got this, again, this balancing act between naturalistic, realistic behaviour, external validity, and ethics, essentially, and it's sometimes a difficult balance to make. Then we look at how we design the observation, and generally it's structured or unstructured, and again the kind of controlled and naturalistic lend themselves better to one or another. So a controlled observation is more likely to be structured. You have a set method where you're looking for set behaviours, so that's the strange situation. They were looking for exploration behaviour, they're looking for separation anxiety, stranger anxiety, reunion behaviour, for example. So that's quite structured. The benefit of that is that you're probably more likely to get quantitative data. It's better to replicate. You can compare answers, easier to analyse. However, the external validity is more difficult, and actually you then might miss something. So those were really the only 4 behaviours that Ainsworth and her team were looking at. So did they miss anything because it was so controlled? Whereas an unstructured interview is more natural. You're seeing people in the park, you tend to get more qualitative, richer detail, but again you might have some sort of observer bias in there, and it might be harder to compare one observation with another. Linked to this, you need what's known as behavioural categories. These are really, really important in observations. What are you actually looking at? So that's a behavioural category. And this, again, is like the reunion behaviour in the strange situation. It's almost the equivalent of operationalisation for experiments. What are you actually looking at? You would want to train different psychologists to be looking at the same thing. And remember, when we're talking about psychology and behavioural categories, a behaviour is observable. So happy is not a behavioural category, but smiling is. And if someone smiles, you might feel they're happy. Again, crying is a behaviour, but sadness isn't. That's the emotion. And so remember, when you're looking at behavioural categories, they need to actually be observable behaviours. Again, so if you're looking at aggression, well, that's not a behavioural category, but punching, hitting, kicking, etc. is. You need to be objective when you're creating your behavioural categories. It's hard to include all behavioural categories as a weakness. And another weakness is sometimes it's hard to distinguish. So what's the difference between a grin and a smile? Or I just said hitting. What's the difference between a hit and a punch, or a punch and a slap? You'd have to train your your experimenters quite well to be able to distinguish between the different behavioural categories. And then, as if there weren't enough definitions in research methods, I'm really sorry, it's part of the spec, you have to know all these terms. Get a Quizlet going if you've not used that, have a look at Quizlet.com, it's quite good for learning new terms. Essentially, you're learning a new vocabulary, a new language when you're learning research methods in psychology. But we've got this event and time sampling. Now, students normally confuse because I spoke before about sampling methods. So sampling methods, as in random, volunteer, opportunity, systematic, stratified, they are how you get your participants into your study. This is slightly different. This is almost observational sampling. So within observations, you can have either event or time sampling, and this is what behaviours are you looking at, and how do you look at your behavioural categories. So the two you need to know about. Event sampling is when a particular event happens, you record that event, whereas time sampling is where you might look a particular time, so the first 5 minutes of each hour. Why you would use one or the other, it depends what you're looking at really. So again, with Ainsworth, her team were looking at particular behaviours. They wanted to know what the infant was doing when they were in the room with the mother. They wanted to know what happened when the mother left. They wanted to know what happened when the stranger came in. So that would be event sampling. But if you wanted to look at, I don't know, how children were to have sharing or playing behaviour with other children during the school day, and how that changed over the day, whether they got tired, actually time sampling might work better. So you might look at the first hour of playgroup or nursery, but actually you can't record the whole hour, it's too much to record. So what you might do is record the first 5 minutes of every hour to see if their sharing and cooperative behaviour change throughout the day, so between 8 and 9, 9 and 10, 10 and 11, etc, etc. So that would be time sampling. So it depends on what you're looking at, and how you're setting up your study would depend on which one you would use. Again, they come with strengths and weaknesses. So if there's a specific event you're looking at, if it's infrequent what you're looking at, then that's a strength of event sampling. But actually, if the weakness of event sampling is you miss everything else. If you're only looking for certain events, then you miss the rich, detailed information, and you might not have thought of some of the behaviours that you actually do end up seeing, and so you'd miss them. For time sampling, it's fewer observations. It narrows down what you need to look at. It allows you to actually look at specific things, but it's potentially unrepresentative. And first 5 minutes of every hour. Well, what are they doing for the rest of the hour? Again, you're missing lots of things. And it's hard to know and hard to tell what you'd actually end up missing. Next, we've got self-report data, and self-report data is data that people report themselves. No shit, Sherlock. And so there are two different types of self-report data. First, you've got the interview, which tends to be face-to-face and verbal, or you've got the questionnaire. So that is more written, it's on a form, and it's a preset written questions. Both of these could be open or closed, and so you could have or structured or unstructured as well. So you could have a open interview, so that's where the responses are limited if they're open, whereas closed you've got limited responses. So with the interview, tend to be structured, easy to replicate. The unstructured is more flexible, which is great, but you then kind of got the vice versa with the weaknesses. So the structure is great, that it's easy to replicate, but it's not as flexible. However, with the unstructured, because it is flexible, it's hard to replicate and compare. So you've got that decision to make whether you go structured or unstructured for the interviews. For the questionnaires, they tend to be quick and easy to compare. You can have open and closed questions on the questionnaire again. Probably more likely to have closed, Likert scale, so that's a scale of 1 to 5 or 0 to 5, 0 to 10. Or you can have open questions. What's your opinion on whatever it may be. So quick and easy, you can send them out digitally, you can get people to fill them in, tend to get quite quantitative data, especially if they're closed questions, which is really great. But both for a questionnaire and an interview, you've potentially got social desirability bias, which is where participants might give responses that make them look better rather than what they actually mean. Whether you get more social desirability bias in an interview or questionnaire, I guess that's kind of up for debate. Is it easier to lie to someone's face in an interview, or would you want to come across better to someone's face? Whereas with the questionnaire, I don't know, is it easier to put what you think on a questionnaire? Maybe. Open and closed. So open questions tend to give you more qualitative, rich, detailed information, which you might not have looked at that, you might not have thought about that, which is really great. However, weakness, those are harder to compare, so it's harder to put those in graphs and charts and do statistical tests on them. Whereas with closed questions, it's easier to quantify, easier to statistically analyze, easier to replicate. However, obviously you can't expand and you haven't got that richer detailed information. So yeah, you should be getting the idea now that lots of research methods, a strength of one is a weakness of another and vice versa. So you haven't actually got to learn hundreds of different evaluations. Moving on, correlations. I've put these kind of on their own and done it slightly differently because correlations are a bit of a law unto their own. So it's another method. So you've got experiments, observations, self-report. You've got correlations. Correlations tend to be, well, you can do both primary and secondary data for a correlation. The big thing here is you need to be aware that a correlational hypothesis is different to another hypothesis. So correlations are known as tests of association. So your hypothesis needs to match that. You can have a directional hypothesis for a correlation where you said there's going to be a positive correlation between, I don't know, number of hours of violent video games played and aggression score. That's quite a common one. Or you can have it non-directional. There will be an association. So you're still getting directional, non-directional, but you need to be aware of those terms, association or relationship. Again, you can have a null hypothesis. There will be no correlation, no association between aggression score and number of hours of aggressive TV watched. Something that you need to be aware of again is correlation coefficient. The definition of that is a numerical value that gives the strength and direction of a correlation. So it runs between -1 and 1. The closer to either -1 or 1 it is, the stronger the correlation. So if it's a negative number, it's a negative correlation, hence the direction of a relationship that the correlation coefficient gives, and then the strength, so the closer to 1 it is. So a -0.75 is a stronger negative correlation than a -0.25, for example. And yeah, you need to be aware of that. And as well as that, they have their own graph. So if you ever get a correlational study or you read a hypothesis that says association, the graph that you have to use is a scatter graph. I'll come on to the other types of graph in a moment. Again, there are strengths and weaknesses of them. They tend to be quick and easy, economical. However, you cannot have cause and effect. So a common mistake is for people to see a correlation and say, oh, this means that if you play aggressive video games, you're going to be more aggressive. No, there's just an association, there's a relationship. It could be that there's personality traits behind it driving people towards both. There's a third variable. There's actually a correlation between number of shark attacks and ice cream sales. It doesn't mean there's a link between those two things. There's the third variable of temperature, which makes those two things a lot more likely. But they can give an indication of where to research further for other studies. And then finally, I've just kind of labelled this other bits that are in the spec that you need to know, not necessarily strengths or weaknesses here, but you do need to have an awareness of them. So you've got pilot studies, small scale versions of the full study. They allow you to test things such as timings or questions that you're asking before the main study. It means that you won't waste time and money and effort in trying to get data that then turns out to be not very good. Psychology and the economy is something else that's mentioned in the spec. It's mentioned under the research methods topic, but actually what you need to do here really is related to the other topics that you look at. So a good one here is the role of the father, because lots of the research tends to look at the mother as the primary caregiver, so she may be off work, and so that has an impact on society. So where it says psychology and the economy, read that really as kind of gaining or losing money. Another way to look at that is psychopathology. That's what an area this comes up in again quite a lot. So cost of drug treatments maybe to the NHS is a cost, but actually if people are then receiving treatment for mental health problems, they might then be able to get back into work and then be paying into the tax system. So that's the sort of thing you need to be aware of. Percentages, you need to be able to calculate a percentage. You need to be able to calculate percentage increase, percentage decrease. These all of these actually tend to be all of these other bits tend to be AO2. So you're going to be doing stuff that'll actually ask you to calculate those things. So be aware of that. As well as that, turning decimals into fractions, fractions into ratio, ratio into decimal, etc., etc. So these are all math skills. Again, this should be your GCSE. And if you're not so confident on that, that's something you're going to need to go back over. And meta-analysis is a study comprising of other studies. So you might have, again, looking at the other topics, Van Isendorn and Cronenberg did a meta-analysis of strange situation studies. So they looked at lots of other studies that have looked at the strange situation and tried to find cultural variations. The benefit is that it tends to increase the sample size, and so the effect size potentially is better in a meta-analysis. However, the weakness is the file drawer effect that I spoke about before, where actually you only tend to see published research. So there's kind of strengths and weaknesses to doing a meta-analysis. Bar charts and histograms, you need to know the difference between them. You can get asked to draw them, most likely get asked to draw them. Marks, generally a full marker, you get a mark for doing the title, don't forget that. The big difference between them for psychology, for the A-level AQA, is that for the bar chart, you need separate bars because it's categorical data, it's discrete data. These things aren't linked together. So if you were looking at the first pet that was bought by people at your school, you'll have dog, cat, gerbil, hamster, ferret. I don't know what other weird things people buy. Those bars are distinct and different, and so it doesn't matter what order they go in, the bar chart would still say the same thing. Whereas with a histogram, it's known as continuous data. And so the bars have to be in a certain order. If I were to plot the heights of people at school, it wouldn't make sense for me to have 6 foot to 6.5 foot first, because there are people with smaller heights. That data needs to be continuous. That's the big difference you need to be aware of. You need to put the axes, and you need to draw them appropriately. That's generally the 4 marks: title, well-labelled axis, making sure the bars are either separate for a bar chart or touching for a histogram, and then appropriate scale. You've also got distributions. Again, these are things to look at: normal, positive skew or negative skew distributions. Might go near the standard deviation stuff that we looked at before. You need to be able to identify them. You need to know where the mean, median, and mode go. So the mode, the most common, will always go at the peak of the graphs, whereas the mean will get dragged to the center, wherever that may be, by the extreme scores, and the median, the middle, well, it tends to go in the middle of those two. Then you got the sign test. Again, that's your introduction to statistical testing. You need to be aware of the significance level in psychology, 0.05. You need to know the observed value is your S. S equals the number of fewest signs. You need to be able to compare the calculated value with the critical value. To read the critical value, you need to know N. N is the number of participants minus the people that have got the same score. I don't know what else to tell you about that. Again, kind of read over it. And then you've got single and double blind studies. So a single blind study is where the participants aren't aware of the aim of the study, so they don't have demand characteristics. A double blind study is where neither the experimenter or the participants have know what the study's about. So you'd get maybe different researchers than the person that came up with the study to carry out the study, and that'll get rid of investigator effects, because if they don't know what the study's about, how can they give away the aim to the participants? And about done. So yeah, it's a massive topic. I don't envy you having to learn it all. It is just a load of terms, so go over them. The way you'll get tested on this, funnily enough, is hardly ever you'll get asked what is a independent measure design. Quite often what's going to happen is you'll get asked you'll get given a scenario in the STEM and get asked to identify the design. So it's AO2, you have to do something with it, or asked what is the strength of a independent measure design. And again, the term you'll hear is in this study, in this investigation, in this experiment. That's context AO2, and that should tell you that you need to relate your answers back to the STEM. That's the biggest bit of advice I could give you with answering these questions. So actually, you need to know the AO1 so you know what it is, but you won't get tested on that very often. It's normally you'll get tested on the application and the evaluation. Good luck.